We've seen this word before, right? Heterogeneous. What does that prefix hetero mean? Different, right? Heterogeneous equilibria. So the chemical reactions we've been talking about so far in terms of equilibria have involved gases only. Now we've got some that have maybe some other states in them. So here's a solid, and one of the products is a solid, and there's a gas. And so there are different states. It's heterogeneous. There's a gas and solids. When we have solids or pure liquids in a reaction, we don't include their concentrations in the equilibrium constant expression. The equilibrium constant expression for this is just the concentration of CO2, which is not necessarily what you would expect. I mean, just looking at what we've done before, we would expect that the KEQ would be the calcium oxide times the carbon dioxide divided by the concentration of calcium carbonate. That's what we would expect, right? Well, calcium oxide is a solid. How do you change the concentration of a solid? Let's maybe ask a different question. How can you change the concentration of a gas? You could compress it, right? If you compress it, put pressure on it and squeeze it into a smaller volume, now the particles are going to be closer, right? We can do that with a gas. Can we compress solids and make them more concentrated? No. The concentration of a solid is always the same. It really depends on the density of the substance. So if this concentration can't change, what's the point of having it in the equation? There is no point, so we don't include that. This one is also a solid. The concentration of solids can't change. It doesn't change, so we leave it out. So the equilibrium constant for this equation here is just the concentration of the carbon dioxide gas. The same is true for pure liquids because you can't compress liquids either, so their concentrations can't change. And I'll just tell you, we're talking about these equilibrium expressions and stuff. We're staying very much at the surface level. There's a lot more to this. If you take Chem 1, actually Chem 2, you'll get into it a lot more. So write an equilibrium expression for this chemical reaction. KEQ equals what's going to go on the top? Are we going to use the water at all? No, because it's a liquid. Its concentration doesn't change. So it's just going to be the chlorine. And what do we do with this 2? So this is squared. And then what's on the bottom? The concentration of HCl raised to what power? 4. And the concentration of O2 raised to what power? 1. So concentration of products divided by concentration of reactants. Whatever the coefficient is, that becomes the exponent for that particular substance. If you have liquids or solids, here we have a liquid, leave it out. We leave it out because it doesn't change. It just doesn't matter.